हेलो एवरीवन, वेलकम टू सनराइज क्लासेस। आज हम इस वीडियो में डिस्कस करेंगे एड्रेसिंग मोड। एड्रेसिंग मोड इज एन इम्पॉर्टेंट टॉपिक इन कंप्यूटर ऑर्गेनाइजेशन एंड आर्किटेक्चर। हम इस वीडियो में डिस्कस करेंगे एड्रेसिंग मोड क्या होता है, एड्रेसिंग मोड क्यों यूज करते हैं, एंड व्हाट आर द डिफरेंट टाइप ऑफ एड्रेसिंग मोड। वी विल डिस्कस ईच टाइप इन डिटेल्स। ओके, सो लेट्स स्टार्ट दिस। फर्स्ट, in the previous video we already discussed that there are two type of architecture. Computer architecture is two type. One is RISC and another is CISC. RISC is called the reduced instruction set computer. CISC is called the complex instruction set computer. तो ये सारे जो एड्रेसिंग मोड है that is basically comes under the CISC architecture. इन CISC आर्किटेक्चर क्या होता है, दोनों में क्या डिफरेंसेस है, कंट्रोल यूनिट क्या होता है, अगर आप ये जानना चाहते हैं तो आप मेरे पिछले वीडियो को देखें। अभी हम बात करते हैं इन CISC द इंस्ट्रक्शंस विल बी द हैविंग टू पार्ट्स. वन इज द ऑपकोड एंड अनदर इज द ऑपरेंड. दिस इज द इंस्ट्रक्शन. सो ऑपकोड is the instructions. For example, it's add, move. This is the opcode. It will tell you which instructions we have to perform, and operand will tell you on which data we have to perform this operation. So effective address is an address where actually data resides in memory. So effective address, we understand the effective address. Then the addressing mode is a method or is a mode to find out the effective address from this operand. From here there will be the 0 1 or something will be there, register will be there. So using that, whatever the value is here, we have to find out the effective address, that is the addressing mode. For example, there is one instructions. Let's talk about any instructions. For example, okay, let's take an example of one operation and see how this addressing mode is working. So I am going to take an example of add. So there will be add R1 and B. So what is this? B is a variable, and what will happen, the actually the instruction will be converted in this format: R1 equal to R1 plus B. Okay, so what is happening here? Here B is a variable and R1 is a register. So in computer, what is happening, there will be RAM, and there will be set of register. So for example, we have a register, 16 register is there. 16 is general purpose register, it will be there. So that will be starting with R0 to R15. And here there is a memory of 2 to the power 20, for example. So this is the size of this RAM. So okay, now what will happen if you wanted to give address where the B is there? Okay, so for example, B is going into the RAM and finding the addresses. So these addresses, to represent these addresses, we need 20 bits. You got it? Because there is one word between this RAM, so that will be represented by 20 bits. So what will happen here? And the R1 is only we have a 16 register, so there we need only 4 bit, and here we need 20 bits to represent in right addresses. So here what will happen, the instructions length will be 20 plus 4 equal to 24. But if you wanted to reduce this, what we can do, we can store this also in a register. For example, what I will do, I will go and I will tell you that R1 plus R5. So what will happen, they will go to R5, and R5 having addresses of this one 0101, something will be there for 20 bits. So these addresses will be there. So what will happen, if I will give R5, R5 will come here, and from here it will come to this address, and they will find the right variable, right value, right data. But here instructions length will be only 4 for the R1 and 4 for the R5, so only it will become 8 bit. So this addressing mode is used to decrease the instructions length. So what will happen, they are giving the addressing modes in a way that you can use the huge number of memory, but the instructions length will be less. So they are going to reduce the instructions length. So this is the one use of the addressing mode. Okay, there are two types of addressing mode is there. One is sequential control flow of the addressing mode. Another is the transfer of control flow. Here, transfer of control flow basically is discussing about the inter-segment communications. So, for example, in RAM, some piece of code is there from 100 to 500, and some piece of code is there 2000s to 2500. So they have to communicate each other. So here it will come the transfer of control flow. That is basically focus on the instructions, what instructions needs to be executed. But here it is focused on the data. Okay, now in sequential control flow there are two type of addressing mode. One is based on the register, another is based on the memory. Memory means the RAM. Similarly, in the transfer of control flow, it is only one type, that is based on the memory. Let's talk about the different addressing mode quickly, and then we will go and discuss in the details. So first, there are two addressing mode based on the register. One is the register mode, that is a direct, and another is the registered indirect mode. In register mode, direct is simple. We have just given the address, for example R1, we have given R5. So this is like simply we are giving the register. So it will take the data what is mentioned in this register directly. So one register having the data directly. But register indirect mode, register should have address of register should have an address of where the data is there. So what will happen, that is the RAM. So it will go to this place and then it will fetch the data. So that is the register indirect mode. Now let's talk about the memory based addressing mode. So first one is the implied addressing mode. Here what will happen, some of the instruction is like where operand is not required. So CPU by default understand which operations on which data they have to perform. For example, we have to set the carry. So for that they are using the important thing is here, they are using accumulator for this purpose. Accumulator register they are using for this register. So for example, set carry or clear carry, this is the, you have to just give the operand, we have to just give the opcode. There is no addresses is required, there is no operand is required. CPU by default understand on which register they have to perform. So this is the implied one. Immediate addressing mode, here by directly we are giving data. Direct addressing mode, see here, direct addressing mode is also called as the absolute addressing mode. Okay, so direct addressing mode, we will give the address, for example A, and we have to go in the RAM, find out where is this, and then they will find out the data from here. Okay, indirect addressing mode. Indirect addressing mode, what will happen? It is using pointer. Okay, so what will happen? You will give the address, for example, uh, for example B. So what will happen? They will go to the address of B So this is for example the value. Okay, now it is coming here. From here they will find another address, and this is the effective address, and from here they will find the data. So you see there is a two cycles in memory. So this is the indirect addressing mode. Index addressing mode is based on the sum of the set of registers, increment and decrement. Base addressing mode, this is also based on the registers. I will discuss this one in later. Similarly, let's discuss control flow, transfer of control addressing mode. There is a two things are there: PC relative addressing mode and the base register addressing mode. These all are based on inter-segment communications. Thank you very much. If you think that this is useful for you, so please subscribe and share with your friends. Thank you very much.